Okay. Next major statistic we use for interpretation is predictive probabilities. Predictive probabilities. So for any set of values of the independent variables, the predictive probabilities can be computed. First is lambda, as I demonstrated in last slide, right? It's exponential of x beta over 1 plus the exponential of x beta, and the probit. Probit is integral, right? From negative infinity to x beta, right? X beta, and we take integral of probability density function for the standard normal, right? I'm not getting into all the messy mathematical details. And okay, and when we compute predictive probabilities, we don't have to use observed x. Sometimes we can use hypothetical values for x. Okay, so let's say if we're interested in the predictive probability of let's say labor force participation for a 35-year-old female with 10 years of education, and if we don't have that case in our sample, we can still feed that X vector to our R program and produce predictive probabilities as well as its associated precision estimates. Okay, and yes, in that case, we call that ideal types sometimes, or hypothetical predictions. And what kind of setup we can have for predictive probabilities? Well, a common practice to get predictive probabilities is to hold all variables at their mean. That's one possibility. That's just one possibility. But that's very commonly practiced. When the independent variables are highly skewed, okay, when the mean does not represent the center of the distribution, then what's going to happen? We better use median, right? A lot of times. Okay. And here's for dummy variables. So variables that are coded 1 and 0. And sometimes we have one dummy if we have a binary indicator variable, right? And other times we could have multiple binary, dummy variables for a multinomial, multi-category explanatory variable. Okay? And so what we can do, we can either use the average, the mean, the sample mean of that dummy variable. Literally, that is the proportion, equivalent, that is proportion with, that dummy variable equal to 1. And then the predictive probability is between the probability at dummy equal to 1 and dummy equal to 0. Okay, you can try that out. And the second possibility is to compute the predictive probability for each combination of the dummy variables with the other variables have their means. If we have multiple dummy variables, okay, one dummy is 1, another dummy is 0, etc. And the different combination correspond to actually different, sometimes hypothetical groups or types of individuals. And the third possibility for feeding values to dummy variable is to hold dummy variables at their model values. If a combination of variables is of particular substantive interest, those values can be used as a baseline. So for somehow you're just obsessed with, let's say, the probability of labor force participation, right? Y equal to 1 for a 35-year-old female with 10 years of education. Well, you can feed that set of X values into the program and compute